Section P.7, Part 3. So we're going to start off with something that should be fairly easy, should be a review for you. And another way of solving quadratic equations is by using the quadratic formula. Anytime that you could not factor down a trinomial, the quadratic formula was helpful for figuring out what those answers or those roots were. So it says the solutions of a quadratic equation in general form, ax squared plus bx plus c equals 0, with a not equal to 0, are given by x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So, for example, solving using our quadratic formula, we have a 2x squared plus a 2x minus 1 is equal to 0. So we need to make sure we can identify our a value, which in this case is going to be our a value, our b value, and our c value. A is equal to 2. B is equal to 2, C is equal to negative 1. And if we go about filling that in, we know that X is equal to negative B. Remember, negative means the opposite of whatever B is. So if B is a positive 2, the opposite of positive 2 is going to give us a negative 2, plus or minus. We have our square root of. For the sake of just filling it in terms of notes, we'd have B squared, so we'd have 2 squared. Minus 4 times a is 2 and c is a negative 1. And then that whole thing gets to be divided by 2 times our a value of positive 2. And if we simplify that down, we're going to end up with, we have a negative 2 plus or minus, we have a square root of 2 squared is 4 minus 4 times 2 times negative 1. 4 times 2 is 8. 8 times a negative 1 would be a negative 8. So if we're subtracting a negative 8, that means that we're adding 8. And we're dividing that by 4. So we have a negative 2 plus or minus the square root of 4 plus 8 gives us 12. And then we're not quite done yet because the square root of 12, we need to simplify that down a little bit. So if I were to simplify that, we'd have a negative 2 plus or minus. 12 is the same thing as 4 times 3. Square root of 4 gives us a 2 square root of 3. And then we're dividing by a 4. And all of those numbers are even numbers. So that means we're going to end up with a negative 1 plus or minus the square root of 3 divided by 2. And that's what x is going to equal, right? Because 2 divided by 4 would be a 1/2. 2 divided by 4 would be a 1/2. But I don't need that second 1/2 since I have just that square root of 3 in there. Now, the other piece that we're going to look at in terms of that quadratic formula is what's called the discriminant. Not sure if in Algebra 2 you talked about the discriminant much or not. It says we can find the solution for a quadratic equation of the form ax squared plus bx plus c equals 0 using the quadratic formula. But within that quadratic formula, we have what's called the discriminant. And the discriminant is the quantity b squared minus 4ac, which appears under the radical sign in the quadratic formula. The discriminant of the quadratic equation determines the number and type of solutions. Number meaning how many solutions we're going to have. Are we going to have 0 solutions, 1 solution, or 2 solutions? And also the type of solutions. Are they going to be real numbers? Are they going to be imaginary? Right? Remember, imaginary comes into when you're taking the square root of a negative number, right? The square root of a negative number. So let's see. The types of solutions that we could have within that tells us if the discriminant is positive, there will be 2 unequal real solutions. Meaning if we take that b squared minus 4ac, if that is greater than 0, that's what it means to be positive. It's greater than 0. We are going to have 2 unequal real solutions. If you remember, within that quadratic formula, we had that plus or minus the square root of all that stuff. That plus or minus is kind of what gives us that little hint that we're going to have 2. We have the plus version and we have the minus version. It then says if the discriminant is equal to 0, so if our b squared minus 4ac is equal to 0, we're only going to have 1 real repeated solution. If I were to end up having that discriminant equal to 0, I would take the square root of 0, which means we would have had a plus or minus square root of 0, which means that we are adding and subtracting 0, which means all we're left with is whatever number would have been up here and whatever number would have been in the denominator of that quadratic formula. The third part says if the discriminant is negative, that means your b squared minus 4ac has to be less than 0 to order for it to be negative. Then you have two imaginary solutions. Two imaginary. Remember, imaginary is the square root of a negative number. So if that discriminant is negative, you have a square root of a negative, which is what then tells us that we have those two imaginary solutions. So let's see what happens when we try one. All it wants us to do is compute the discriminant of 3x squared minus 2x plus 5 equals 0. What does the discriminant indicate about the number and types of solutions? So all we need to do is figure out what our b squared minus 4ac is. So we have our a value, our b value, and our c value. If I take my b value, which is going to give us a negative 2, that is squared, minus 4 times an a value of 3 and a c value of 5. That means that we end up with a positive 4 minus 4 times 3 is 12. 12 times 5 gives us 60. 4 take away 60 leaves us with a negative 56. What happens if we have a negative? Well, it says because the discriminant is negative, that means that we are going to have no real solutions, or we would also kind of state that that's going to end up giving us two imaginary solutions. Remember, the imaginary has that the letter I in it when you take the square root of a negative. Okay. So radical equations. It says a radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. It says we solve radical equations with nth roots by raising both sides of the equation to the nth power. Sometimes we have a second power, sometimes we have a third power, sometimes we have a fourth, fifth, whatever power that we may need. So solving some radical equations containing nth roots. It says if necessary, arrange terms so that one radical is isolated on one side of the equation. Step 2 says to raise both sides of the equation to the nth power to eliminate the isolated nth root. Step 3 says to solve the resulting equation. If this equation still contains radicals, repeat steps 1 and 2. And step 4 says to check all proposed solutions in the original equation. So, I have a square root of x plus 3, and then I have a plus 3, and that whole thing is equal to x. So it says to isolate the radical on one side. So if I want to get the radical all by itself, that means I need to get rid of that last part that says plus 3, and we do that by subtracting 3. That means we're left with the square root of x plus 3 is equal to x minus 3. Step 2 says to raise both sides to the nth power. Well, we're taking a square root, which means I need to square both sides of our equal sign. Well, by now, I hope you understand that if you have a square root and a square, that cancels each other out and you're just left with the x plus 3. And then if I have an x minus 3 squared, we might as well double square that. That's going to give us our x squared minus 6x plus 9. When in doubt, FOIL it out. Step 3, solve the resulting equation. Well, now if I need to figure out what x is, I need to get everything to one side of the equal sign. That means I want to subtract x, and I also want to subtract 3. That way I have 0 is equal to, I have an x squared, minus 6x, a minus x is a minus 7x, a plus 9 and a minus 3 leaves us with a plus 6. And then I want to solve the resulting equation. Now, we've done this several ways. We could check to see if it could be factored. We could check to see, can we complete the square? We could check to see, do I just use the quadratic formula? So there's actually on page 100, solve the resulting equation. Page 100 has a table that kind of gives you some hints as to what is the best method for solving any sort of quadratic equation at that point. When I look at this, I always double check. Can I multiply to make 6 and add to make 7? If it can be factored, break it down into your two sets of parentheses. If it can't, and you want to try completing the square, go for it. If you want to go ahead and do the quadratic formula, go for it. Either way, we need to get x all by itself. So let's solve this down. 0 is going to equal we kind of already hopefully know that this can be broken down into x and x. Multiply to make 6, add to make 7 would be 6 and 1. They both have to be subtraction signs in order to end up with a minus 7. So let's see what we got. X minus 6 is equal to 0. That means x equals positive 6. X minus 1 is equal to 0, which means that x is equal to positive 1. And step 4 says to check the proposed solutions. That means I want to take and plug some numbers in. So I want to see if I were to take the square root of 6 plus 3, if I add 3, will that equal x, which is 6. 6 plus 3 is 9. The square root of 9 gives me 3. 3 plus 3 is equal to 6. I know that that works. If I try 1, square root of 1 plus 3, and then I add 3, is that going to equal x, which is 1? 3 plus 1 is 4. Square root of 4 gives me 2. 2 plus 3 equals 1. That is not going to give us a solution. So the only solution I end up with in this case is that x is equal to 6. That is why it is very important to make sure you check that your solutions work.